Missed an episode of your favorite podcast? Choose from over a decade of content in our archives, not just the latest episode. All free at gcnlive.com.
This is your call to action. Get prepared, America. Economy, survival, energy, disasters. This is USAPrepares.com. Informative radio, educational radio. Interact now by emailing instructor@USAPrepares.com or text at 434-390-7953. Class, please take your seats. Now, your instructor, Vincent Finelli.
Everyone all set? Cocked? Locked? Here we go. Your dial set correctly to USAPrepares.com. We're delighted you're here, and we're broadcasting 2 hours from high atop the Missouri Ozark Mountains. If you'd like to call us when we're live, that's 9 a.m. through 11 a.m. Central Time, 866-582-9933, 866-582-9933. And if you'd like to take us with you as you travel, we have a telephone listen line that works great. Actually, we have many telephone listen lines, but let me give you one of those numbers, 605-477-3249. 605-477-3249. John is engineering the broadcast in Minnesota at Genesis Communications Network. I'm Vincent Finelli, and I'm delighted to be broadcasting with Rhodes Carter of Iron Edison. Welcome, Rhodes.
How you doing today?
I'm doing well. You know, I'm getting ready to go to a conference, and it's the RK Prepper Show in Kansas City, Missouri. So Dr. Richard Allen Miller, one of our senior instructors, will be there. Dr. Joel Wallach, senior instructor, will be there. Matt Stein, senior instructor, will be there. Storm and Norman Cantwell will be there. Let's see. Craig Douglas will be there. And I'll be there. There'll be 6 of us from USA Prepares at least. And we're going to be on stage, and we're going to be talking about all kinds of preparedness types of things. And that's at the KCI Expo Center in Kansas City, Missouri, Saturday and Sunday. So I'm excited about that. And so I'm ready to go. Looking forward to meeting some of the team. And I'm excited about the prospects of, you and I broadcasting live from the same studio or from an event together. And that'll be fun as well, Rhodes.
Yeah, and those prepper expos are always a great time. You learn quite a bit of neat stuff. There's actually one coming up at the end of October here in the Denver area that myself and a few others from Iron Edison are going to be at, doing some presentations about solar energy systems and things like that. So if you're in the Denver area, be sure to check that out. I don't have the details in front of me, but I could look them up and have them for you later in the show.
Okay. Well, please do that, because as the event gets closer, I want to make sure that our class is aware of where you're going to be, and they can meet you in person and bring their notes with them and get all their questions answered. So yeah, please let me know, when a week out or so, and we'll be glad to help you with that and make sure that we get the message out, to all of those who are interested in attending. We talked about different types of solar systems in the past year, and of course, you're a systems designer with IronEdison.com, the very same IronEdison.com that I purchased our solar system from, and I'm delighted. I'm delighted with the quality, the delivery, the expertise, the telephone support, and that's why I've invited Iron Edison to be instructors. Brandon Williams, the CEO, Rhodes Carter, and actually, I think we've had at one time or another almost every member of the team, except for the new hires, right, on the air with us.
That's right. Yeah, I think it was a couple months ago now. We did a couple shows with you, kind of a roundtable format where we had most, if not all, of our system design staff on talking about various aspects of solar and renewable energy and energy storage in general.
Mm-hmm. So today we will talk about grid-tied system, off-grid system, hybrid system, batteries, and also who is interested in buying these systems? I know the phone rings at Iron Edison, and I'm very curious. Who are interested in buying an off-grid or a grid-tied or a hybrid system? What can you share with us? Not specific names and addresses, but walks of life, and why? Why are people calling you do-it-yourselfers? Are they people who are saying, no, yeah, I don't know enough about this, but I trust you to design that system, and here's what I want. What are those phone calls like?
Our customers cover the entire gamut of energy storage needs. Everything from someone who has a small one-room hunting cabin that's completely off the grid that needs just to power a couple lights, maybe a radio. To the other end of the spectrum, we're getting calls from the utility companies looking for large-scale energy storage solutions to do things like grid smoothing, production shifting, peak load shaving, things like that. So we have customers looking for a very small battery up to batteries that fill several 40-foot shipping containers. So really, it's just a broad spectrum of interest in people looking for various, not only renewable energy systems, but just energy storage solutions in general.
Mm-hmm. When I was in California, we had a company, we did a startup, and we manufactured satellite communications equipment. And one of the things that we did was we had like events at our company, and we would invite people who were interested in that technology at the time to come on over and meet with other people who were interested in that technology and with us, and we trained them. Do you have any plans for that in the future? I know we have not discussed any of this, but do you have thoughts about doing the kind of training that you'll do at a preparedness expo, but at your location?
Not necessarily at our location here in the Denver area, but certainly at preparedness expos, other trade shows. It's actually very common for us to give an hour or so presentation to kind of give people a primer as to what is a solar or renewable energy system. There's a lot of misconceptions out there as far as, I'm just going to get some solar panels, put them on my roof, and if the grid goes down, no problem. My solar panels are going to power the house. Life is wonderful, but that isn't necessarily the case all the time.
Yeah, I remember that I experimented for the very first time with 2 Kyocera solar panels and some large truck batteries, the kind that tractor trailer truck batteries, and I hooked them up with a solar charge controller, and I had an inverter. I had all the components, but what I found out very quickly, and this was many, many years ago when I lived in Virginia, what I found out very quickly was I didn't have enough watts of solar panels. And the batteries that I used, the lead-acid truck batteries, although they were large and they were heavy, they did not have the life expectancy that I was hoping for. They lasted maybe a year, and that was it. So what I learned about was depth of discharge. You take those batteries down to, 50% or lower of charge, and you destroy the lifespan of those batteries if you get below 50%. If you take them dead to dead, many times, you've just destroyed your battery bank. So there are some things that you need to learn. And back then, there wasn't as much information available. There were fewer people to call. Have you heard of stories like that as well, where people have experimented and said, I know a lot of things that don't work?
Yes, we have had quite a few calls from customers, with similar stories to what you just described, where they really are not solar experts. They're just getting into it. They think, well, if I got a battery, I can discharge it until the lights turn off on their own and then just charge it back up again. Yes, you can do that, but your battery, just as you experienced, you might get a year or so of life out of it. And that's about it. That's pretty typical with lead acid and a lot of the other battery chemistries that are available today. The deeper you discharge it, the fewer cycles, charge-discharge cycle you're going to get from it. It sounds like you probably discharged your truck batteries, 70, 80% potentially. And with a lot of lead-acid batteries, you might get 200 to 500 cycles in the life of the battery, and that's it. But if you only did a 30% depth of discharge, where you only use the top third of the capacity, for example, you could get 1,000 to 2,000 cycles out of that exact same battery.
Mm-hmm. Interesting thing about that, when you say 200 cycles, what I experimented with was, let's charge these batteries, and it was a 12-volt system, and let's run a refrigerator, and let's see how long it lasts. Well, it lasted a half a day. I was able to run a refrigerator for 1/2 of one day, which didn't work. And when you say 200 cycles, if there are 365 days in a year, and each one of them is bright and sunny, which was generally not the case, I would get less than a year's worth of use out of those batteries if I discharged them too far. And that's exactly what happened. That's exactly what happened.
Yeah, exactly. You discharge the batteries too much, and also you mentioned earlier didn't have enough solar. Probably the biggest misconception I see with people who have a battery-based solar system, they think that their home is solar powered, but really the mindset you need to have is that your home is actually battery powered, and you just have a solar battery charger.
Let me share with the class an analogy that I'd like to get your opinion on. So we have a backhoe, and here at the farm, and it uses two large number 31 size lead acid batteries. So they're like a diesel truck might use this size battery. So there's two of them, and that's what's necessary to turn the starter. And in the past, we found that we'll go out there and we'll need to use this backhoe, and the backhoe is generally not parked right by the back door. It's parked where it's a little more pleasant to not see it. And so we walk over to the backhoe and get into it and turn the ignition switch. And sometimes it would not want to start. And it's tempting. It's really tempting to say, I think it can do it. I think, and it grinds down to where the starter can't turn anymore. But we think that just maybe it'll start. But by doing that a bunch of times, we're destroying our battery, wouldn't you say?
Absolutely. If the engine won't turn over, the battery's already dead. You're just making it worse.
Yeah, and the next time you charge it, it won't come back to as good as it was before. And the next time you do it, it'll be even worse and worse and worse. And pretty soon, it's new battery time. So the point is, if you're in a situation like that, maybe you ought to just try charging it so that you don't damage it further. We'll be right back. Rhodes Carter's with us. Rhodes, I want to share a quick story with you. Yesterday we talked about Hewlett-Packard, and they have a software update that they've been providing for their printer customers. And when some of their printer customers got the update, they found out that the printer cartridges that they were using in their Hewlett-Packard printers no longer worked, and they got error messages. And the cartridges that didn't work were those that were not Hewlett-Packard branded. So some customers were pretty upset, and they called the ink cartridge manufacturers and said, hey, what's going on? And one manufacturer got about 1,000 phone calls. And so we called for a boycott against Hewlett-Packard across the board, every Hewlett-Packard product. And last night I was reading a story that there was so much outrage that Hewlett-Packard apologized, literally apologized for the error of their ways. They have a software update that will be forthcoming that will fix the problem of them requiring you to buy a Hewlett-Packard branded printer cartridge for use with their printers. So what happened was there are a number of people, including those of us at USA Prepares, who have decided to take action, and Hewlett-Packard decided that, you know what, they've damaged their customer confidence, they've damaged their customer trust, and they can't have that continue. So they're fixing the problem. So I wanted to thank our class. Isn't that cool?
That is very cool. I spent a number of years as an IT director before I got into the solar industry, and stories like that, unfortunately, are not uncommon. Mm-hmm. So I am very cautious with software updates because of things like that.
Right. That's a really good point. I'm running an old version of Windows here in the studio, and I keep getting reminded, update, and I go, I think I'm okay, thank you very much. And I just don't do it because I don't, update doesn't mean necessarily everything is going to be fixed and repaired and we are going to be better off as a result. Because I remember in the days when I was in computer technology, and sometimes updates made things worse. So
absolutely. If it's the latest, doesn't necessarily mean it is the greatest. That's kind of the motto I went by in my IT days. And I'd definitely test any updates before deploying them to the systems I maintained. And several times averted a disaster because of that.
Mm-hmm. Yeah. Yep. And in that line of thinking, I want to share with you something I did, because we're going to be talking about grid tie next. We had a bunch of expos, and early in the expo era, there was an exhibitor who had a grid tie inverter, and he had a turbine and a grid tie inverter, and that was it. So I ended up with this, brought it home, and I plugged in the grid tie inverter to a solar array. I hooked it up and, I patted myself on the back. Actually, probably pulled my shoulder out of socket, patting myself on the back, because this was really quick and easy. Plugged it in, and this was working, and I could see the blinking lights, and everything was great. And then I looked at my electric bill, and it went up. It went up, and the reason it went up is because our particular electric cooperative charges by the watt, and they don't care where the watts come from. They don't care if you generate them or they generate them, but they charge for them. So I was feeding electricity into the grid, and they were charging me at retail for the watts I was generating. 10 cents a watt. I was paying them to provide them with electrical current. So those are two little stories about, even though you think you got it figured out, and even though you read on the internet that, you can make your meter go backwards by doing this, I'm here to tell you, I know for a fact that is not always the case. Can you comment on that, Rose Carter?
You learned the hard way there, yes. If you're going to do a grid-tied renewable energy system, a wind turbine like you did, or solar like many, many Americans are doing, first of all, you do need to have a net metering agreement with your local utility. And, of course, that is assuming that they do offer that where you live. There's a few places in the country where net metering is not available or no longer available. And then secondly, they have to give you a bidirectional meter so the meter knows that the energy is going out to them instead of coming in from them. So your bill doesn't get screwed up like yours did.
So, Edison knew about 8,000 ways to make a light bulb that did not work. Well, we learned some of those things too here at USA Prepare. So I'm delighted to be able to share. Class Rhodes Carter's with us, ironedison.com. And the reason that I shared those stories with you about my experiences with the early days of solar is so that you don't have to make the same mistakes. And Rhodes, would it be okay if our class contacts Iron Edison if they're interested in pursuing solar power and are interested in not making some of the same mistakes that I've made? Is that okay if they contact Iron Edison?
Absolutely, Vincent. That's really, as a system designer, I would say probably 50% of my day is spent on the phone with customers, just like our listeners today, just helping them to understand what they're getting into with a solar system, the benefits and the cons to a solar system. I'm not the type of person, and all of us at Iron Edison actually are not the type that are just going to cram a solar system down your throat, pull the wool over your eyes, and get your money and run. No, we want you to fully and completely understand the system you're going to get, or the system you're looking at. Find out what your ultimate goals are and help you to achieve those goals. That's really what I like to do when I'm talking to people.
Are there, when you get calls, do you get calls from people who are absolutely determined to buy a specific brand of equipment? They've done some research and they've figured it out, and that's the only brand they would consider, even if there's a better alternative that you have in mind? Do you get those kind of calls, and then you have to spend some time sharing with them the other choices and why they might want to consider other options? Does that happen?
Periodically. I wouldn't say it's a frequent occurrence. Usually when people are calling, they're kind of just starting out down the road of having a solar or self-sustaining renewable energy system. So really they're, for the most part, going to be open-minded and welcome any knowledge and input to really get what they ultimately want. The people who do periodically call in and just say, yes, I want this system, and I'm not going to consider anything else. Most of the time, that system they want will actually work just fine for them.
That's what happened with me. I did a lot of research, and I determined what brand, what model, and I called your CEO. I was on the phone with him, and we talked about it. And I had in my mind exactly what I wanted to purchase, and he came up with the same exact solution. I mean, exactly. And I was really impressed with that. So I didn't bias him, I don't think, but I knew what I wanted, and that's what he recommended as well, and it worked out great. So
the system that you're putting in at your farm there, Vincent, it is a great system. It's a very robust, versatile, flexible system that will do a lot of things. It's kind of a Swiss Army knife, if you will, of solar systems these days.
And class, if you're wondering what it is, it's the Schneider Electric system. So if you're interested, it's quite impressive in terms of quality and construction and design. Schneider Electric. Now, that doesn't mean it's the only system. It just happened to be the one that fit all of the criteria that I was looking for. So, Rose, let's talk about grid tie. That's one of the types. There's the grid tie system. There's the off grid, and there's hybrid. What is a grid tie system?
Well, grid-tied systems are just that. It's a system that's tied to the electrical grid. And probably the biggest misconception people have is with a grid-tied solar system, if you have a blackout, a grid outage for whatever the reason may be, your solar system is going to go dark as well. The main reason being a grid-tied system, it's very simple, very basic. You've got solar panels and an inverter, and that's it. There's nothing else to the system at all. There's no type of energy storage mechanism at your home. So the way that system is going to work is when the sun's shining, the sun hits the solar panels, they're going to produce as much energy as they can. That energy is then going to go into your circuit breaker box in your home, power any of your electrical loads that you have at that exact second in time. And any surplus that there is then going to leave your breaker box flowing backwards through your power meter, spinning your meter backwards, assuming that you have the correct power meter and you have a net metering arrangement, unlike Vincent learned the hard way, as we mentioned earlier. And then you're going to rack up a credit, typically in kilowatt hours. And then when the sun goes down, your solar array is no longer producing energy, and your home is then going to pull energy back in from the grid, and you're going to consume that kilowatt hour credit that you accumulated during the day, earlier in the day. That's, in a nutshell, how a grid-tied system works. Again, there's no energy storage device, so if the grid goes down, your solar system, actually, it's required by the National Electric Code to shut down as well. So you're not going to have any type of fault tolerance and backup power with just a grid-tied system and a grid outage.
And the reason that it's required that your system shut down if the grid goes down is because the linemen up on the power lines, restoring down power lines or working on the power lines, could be electrocuted because you are feeding the grid that they normally would consider being disconnected while they're working on it, but you could be feeding it with power that you're generating.
Exactly.
And the same is true with a generator. Same is true with a generator. The last thing you want to do is apply your generator's power to the grid and electrocute, utility line workers. So you need to make sure that that does not happen. So what is the cost if someone wanted to just experiment? And I see no reason why experimentation is not a viable option just to get one's feet wet in this. What is a typical cost to have some solar panels and a grid-tied inverter to experiment with? Do you have a feel for that?
There's really no such thing as typical in the solar world. Everyone's electrical needs are different. Probably the most common question I get, people will call and say, I've got, an average single family home. How much is this going to cost? Well, I need to know how much energy you use. That's really the big determining factor on properly sizing a solar system. The average American single-family household is going to draw typically about 30 kilowatt hours of energy a day. I talk to people that may use 10 kilowatt hours a day, and I talk to people that use up to 100 kilowatt hours a day. So really, it boils down to how much energy that you're going to be consuming to properly size a solar system. A grid-tied solar system, you're looking at probably, I haven't checked the national averages lately, but around $4 to $6 per watt of solar array. And household grid-tied solar systems can range from 2 to 7 kilowatts. So, you're looking at the price of similar to a, economy car. That's probably a good, easy comparison to kind of put people in the right ballpark.
When you said 30 kilowatts a day, that's what you find is as an average. Is that correct?
Yeah, that's the national average. Last I checked, is 30 kilowatt hours per day is the consumption of an average single-family American home.
Okay, and I'm right about on that average, as you and I have discussed in the past. But the difference is, I believe we're a little more efficient than the average because we're running an entire farm. We're running a business on 30 kilowatts a day, not just, a residence. And another component of this is we have cows who sometimes drink from a water well that we provide electricity, and they will drink 30 gallons of water a day each. So that's 3,000 gallons of water that we have to pump a day when they're drinking water. And then we have the radio studio and the computers and the lights and the dishwasher and the freezers and the refrigerator and, all the other things that, you have at home in addition to all of the equipment that we have to maintain and keep running. So we're running a shop, a farm, cattle waterers, and a radio broadcasting studio, all from this 30 kilowatts a day. So in our case, 30 kilowatts a day at 10 cents a kilowatt is $3 a day. You're
doing very well, actually, for only, from all those electrical loads you just rattled off and doing 30 kilowatt hours a day. That's very impressive. You're doing a good job.
Well, we're very concerned about efficiency in everything, all kinds of efficiency, and that's why I was delighted to chat with Brandon Williams of Iron Edison, because he understood what we were trying to do, and he was willing to take the time to make sure that we got the right equipment to do what we're trying to do. So as we discuss the grid-tied system, that's the basic system, but what it does not provide, just to recap, it does not provide you energy in the event that the grid goes down. The grid goes down and there is no reserve. It's gone. Electricity is instantaneous, and when the grid goes down, that instant is when you stop having electricity because you don't have a way of storing it, and that would be in some kind of a battery backup kind of a system, right? So
that's correct. Yep, and that's basically is what you're going to be doing as well. There at the farm, you have the grid. You've been using it for quite a while, but you need to add a battery backup component. So when the stuff does hit the fan, you can still turn your lights on.
Well, let's talk about our system. So what we have now is some lead acid batteries because I am looking to be able to pay for the batteries that I would like. So are you finding that other people are doing the same thing, that they're doing it in two steps? One, using lead acid batteries as a short-term step before they go to the more expensive route of nickel iron or another kind of battery?
Lead acid batteries have been the standard, unfortunately, in the solar world since the solar industry really began back in the 70s. Or off-grid solar systems really took off. They're relatively inexpensive. They're mass-produced, but they don't have a very long life expectancy. And, of course, they're very toxic, as I'm sure you know. So that's kind of been the go-to for the industry for many, many years, and still it kind of is. It is kind of the dominant main battery chemistry out there, but just because it is the main go-to choice doesn't mean it's the best.
Yesterday, I was at Walmart, and the reason I was at Walmart is because one of the types of batteries that I bought several years ago was lead acid batteries for one of our trucks. And they have a 3-year free replacement, 5-year life expectancy where they have a prorate for 5 years, but 3 years of its free replacement. And I've never had a 5-year battery last 5 years. It doesn't happen. They get to the point where they can't start the vehicle just around 3 years. And that's the way it's been working for us. And it's not like we don't maintain them. We'll be right back. Rhodes Carter's with us. And Rhodes, the reason I was mentioning this piece about the truck batteries is because typically we found with diesel engines, diesel tractors, trucks, and heavy equipment, 3 years is about all we get out of these batteries. And it's not that we don't keep them charged. It's not that we don't maintain them and check the fluid levels, electrolyte levels, and so forth. The reason I'm mentioning that is I want to make sure that our class understands that if we're using lead acid batteries, if I get 3 years typically out of them, if we get 7 years, that would be pretty darn good. And I want to make sure our class is prepared for that. If they're expecting that this is going to be a lifetime purchase, just getting lead acid batteries at your local battery outlet or Walmart or auto store or wherever you might get them, 7 years is about all they're going to get, right?
If that, and I should probably also point out that with lead acid batteries, you can't just take a typical starter battery from a car that you pick up at an auto parts store. It's a completely different type of lead acid battery. That's called a shallow cycle, where it's really designed to deliver a lot of amps instantly to start an engine. Renewable energy, solar systems, you want a deep cycle battery. It's not going to necessarily deliver, hundreds and hundreds of amps to drive the starter of a motor, but it'll deliver fewer amps over a longer period of time and be much better suited for a renewable energy application.
And we're going to be talking about battery technologies in the second hour more in depth. So let's go to from grid tie. That would be an entry-level system, the least expensive, and maybe something you can learn with. But you're going to quickly want to get off that, I would think, and get toward more like an off-grid system or a standalone photovoltaic system with battery, with a battery bank, so that you can ride out these outages. I mean, that's why we're doing it. We want to make sure that when the grid goes down, we keep going, and our animals don't die, and we don't die. I mean, that's really the plan. So can you share with us what an off-grid system is, Rhodes Carter?
Oh, an off-grid system is much more complicated and elaborate than the grid-tied system we mentioned earlier. The grid-tied system, again, really all it's going to do for you is help negate your power bill. That's it. An off-grid system, that's going to be handy when you have no grid connection, or maybe you do, but you want to have some fault tolerance with a battery backup so that you can keep your entire home or just critical loads up and running during a grid outage. And again, like I said earlier, an off-grid system, really don't think of it as a solar system. Think of it as a battery system. You're actually powering all of your loads from a battery, and then you just have a solar system that's recharging the battery. And not necessarily solar. You could have a wind turbine like you've experimented with in the past, micro hydro, any combination of those that are just going to recharge the battery, and then your battery powers the house as you need it.
You know, as you mentioned this, I was just thinking very quickly, how many of us here at USA Prepares have off-grid systems? We've got Gwyneth, these are instructors, USA Prepares instructors. Gwyneth Isaacs in Australia, who calls me once a week off air. She's got one. Kyle Harris lives off the grid. Rich Sheben in Montana lives off the grid. And Greg Lesher in Utah, all instructors, all living off the grid. And they've been doing it for years. And it works. But you have to plan, right? You just can't assume that you're going to run that toaster, the electric clothes dryer, the electric stove, the electric hot water heater off solar if you have a system that is affordable for most people.
That's right. Yeah, you do need to do a lot of planning and make sure your energy loads are adequate so that you can power your home with it.
And do you teach people how they can shed those watts off their typical electric oven and electric hot water heater and those kind of things to save money on their solar system, which you save a lot of money by changing that hot water heater or changing that electric stove. Do you go through those details with your clients?
That's the first step we do. We go through and do a very detailed energy audit, find out where your energy is being used, and cut as loads as much as possible. Every dollar you spend on energy efficiency upgrades can equal $5 in savings on a solar system.
Okay, let's talk more about that when we come back, and batteries. Rhodes Carter, ironedison.com. Everyone all set and cocked, locked? Hour number 2 of USAPrepares.com. Rhodes Carter is with us, system designer at Iron Edison Battery Company. And if you'd like to contact Rhodes Carter, you can go to ironedison.com, ironedison.com. If you'd like their phone number, corporate phone number, that is 720-432-6433, 720-432-6433. And Rhodes' email address is Rhodes, R-H-O-D-E-S, at ironedison.com. Also, there's a link on the website, usaprepares.com page, the instructors tab. You'll see Iron Edison there, and you can click on that, and it'll take you right to their website. We've been talking about grid-tied systems, solar systems, off-grid systems, and we've been talking about how every dollar that you shed in energy saves $5 in solar energy costs. Rhodes, do you have any further comments about that, or would you like to continue back to how the system works?
No, we can talk about just really energy efficiency upgrades for a minute. A lot of people have the misconception that they can have an all-electric house because they want to be as green as possible and not use fossil fuels in any way, shape, or form. But in the reality of it is, anytime that you use electricity to make heat, that is going to be a tremendous electrical load and can really increase the size of a solar system you would need. And when I say use electricity to make heat, I'm talking about electric cooking. If you have an electric range, electric oven, electric hot water heater, if your dryer is electric, or even if you have electric space heating in your house, like the electric baseboard heating that was real popular in the 70s and 80s.
So, Rhodes, would you say, as a rule of thumb, if you look at the cable, the power cord that you plug in for a device, if you look at that and if it's really heavy, the one from the manufacturer that plugs directly into an outlet, the heavier that is, the more power you can assume that device consumes. For example, an electric clothes dryer has got a really heavy cable. A electric oven, if it's got a really heavy cable. If you look at a charger for a cell phone, it's got a real thin cable coming out of the transformer on the wall. So that doesn't draw a lot of power, but the heavier cables do. Would you say that that's also a rule of thumb?
Yes, it is. That's a great starting point. As you said, these larger devices like the heaters, your dryer, your electric range, those are going to draw just an enormous amount of power. But the other thing to factor in is how often they are being used. For example, a microwave oven, it uses, a lot of power when it's on, but it might only be on for a couple minutes. For example, I just warmed up some coffee here and during the break, and it was on for about 2 minutes. So in the grand scheme of things, that's not a lot of energy, but it draws a lot of power for that minute or two that it's turned on.
Yeah, 1,000 watts or so for 2 minutes. I think that's what you're talking about. Okay, so what about secondary energy sources? There are generators, there's wind turbines, there's micro hydro or low head hydro, meaning water-powered turbines. Can you discuss that a little bit? Because isn't that a way that we can also charge our off-grid system?
Absolutely. They're all great ways to recharge your battery bank in an off-grid system. It really just depends on what resources are available at your particular location. Solar typically is the most common one, mainly because solar prices have gotten so cheap in the last several years. I mean, back 10, 15 years ago, solar panels would cost $10 or more per watt. Today, they're under $1 a watt. So solar has really taken over just due to the economics of it. A lot of people have wind turbines on their property that put a tower, 50 or 100 feet up in the air and have a windmill that's generating electricity. But if you have running water on your property, that's a great source of energy. Doing a hydroelectric turbine actually is probably the most economical renewable energy generation source out there, but not a lot of people have a viable water source that they can do that with.
Mm-hmm. I know a few of our instructors who have springs, and they produce a significant amount of water, and they'd be a great candidate for low head hydro or a water powered turbine. But my son, whenever we drive through Springfield, he sees these wind turbines. And he goes, that's about what we should get, for the farm. And so here's the question. It's not so much the turbine that is of concern to me. It's getting that turbine up in the air. How high do we need to get a typical turbine, in the Midwest? Do you have a feel for that? I mean, you said 50 to 100 feet. That's way up there. That is something that I don't know if we could install ourselves, even with a rig designed to, go up 50 feet. That's a challenge, right?
It is, absolutely. And wind is a big challenge just through the mechanics of it. In general, the higher the turbine is, the more energy you're going to harvest from the wind, because the wind is faster and more consistent at higher elevations. And elevation meaning feet off the ground, not from sea level. But you could do a shorter tower with a larger turbine. There's a balance game here of what's the most practical solution, both logistically and financially at your particular location. And because, again, solar prices have dropped so much, the price of solar panels, the residential wind market is really drying up because of that. People will find it's much more economical just to throw up a bigger solar array and not even mess around with wind. Wind turbines and hydroelectric plants, they're a mechanical device. There's moving parts, so there's more maintenance involved, shorter life expectancy. So there's a lot of logistical issues as well as economics of what is the best renewable energy generation solution for your property.
It's an interesting phenomenon here in the middle of nowhere in Missouri. When the electric utility replaces the power poles going down these dirt roads, they don't like to take those power poles back with them. So literally it's amazing. Literally what they do is they will pull the power poles out of the ground. They'll take the copper ground wire off the power poles, and then they will leave them on the farm along the fence line. So we've got a bunch of power poles that they left here, and we've raised them up off the ground so that they don't rot. And we keep thinking, we're going to use those. We're going to use those power poles. And we're not the only ones that have them. Our neighbors have them. A bunch of us have, wherever there's power poles every 300 feet along the road, they like to leave them. Now, is a 40-foot pole enough to generate wind power in your experience?
Oh, sure. Absolutely. I mean, you can generate wind power only 10 feet off the ground, but you're going to generate more energy the higher it is. So if you have those power poles available to you, absolutely, that'd be a great idea. You might put 2, 3, or 4 of them in the ground and have several turbines going that are just 40 feet off the ground. And that would probably produce all the energy you would need, or certainly be a nice complement to the solar system you already have on the farm.
Mm-hmm. And we don't, in our particular neck of the woods, we don't have people here willing to help us with deed restrictions and telling us that, geez, that's pretty unsightly, or we don't like the sound of it. We don't have anybody here to help us with those kinds of rules, regulations.
You are blessed on that level, I must say.
Rhodes, we built our house, and we were hammering and digging and excavating for 18 months. 18 months here at the farm. There was no house here when we bought it. And then the revenue agent came by us, and she was really confused. She said, I didn't know there was a house back here. So, that's kind of it really is kind of nice not having a lot of help with, with some of the things that we're doing on the farm. Is the next thing to talk about the ultimate, the hybrid, which is kind of like a grid tie plus an off-grid system?
It is, yeah. That is kind of the best of both worlds, or all worlds, really. And it all came about with this new concept called a multi-mode inverter that came out several years ago. And basically, it is set up just like an off-grid system that has been out there for many, many years, except it has a connection to the grid as well. So you can use the grid as a backup instead of using a backup generator, or in addition to a backup generator. So you can pull energy in from the grid if you need to, or if you have a surplus of energy and your battery's full, you have nowhere else to put it, you can push it back to the grid and take advantage of net metering if that's available to you there. So it's a very versatile product. And if actually that's the inverter you have, it falls into the multi-mode inverter category, where, literally it has several energy sources it can choose from: the grid, a backup generator, and a battery bank. And of course, the battery bank will be charged by solar, wind, hydro, whatever renewable energy source you have there. And just in the way we program that inverter, it'll prioritize those energy sources. It'll use the battery first. If the battery drops down to a certain level, it can then fail over to the grid. If the grid's not there, it can then fire up the generator automatically. And it can also push energy back to the grid. It all just depends on how you program the thing.
Mm-hmm. And that's really kind of neat. Now, what you mentioned, fire up a generator automatically. Now, some of us may be thinking, well, I've already got a generator, but it doesn't have a easy to start system. For example, our generator is a military surplus generator. It's probably from the 80s. It's a very heavy device. It's probably 1,000 pounds. And it is the size of a full-size refrigerator. If you turn that refrigerator on its side, that's about the volume of space that this generator uses. And it requires you to preheat the glow plugs for maybe 30 to 45 seconds. And before you do that, you prime it. You make sure the fuel pumps, there are several fuel pumps on this, electric fuel pumps. So you start the fuel system circulating. Then you preheat the air intake system with the glow plugs, and then you crank the starter. So it's a manual process. Now, can you use that kind of a generator? Because that's what our class might be wondering about.
Absolutely. You can't use that generator, but you just have to start it yourself. It can't automatically start.
Yeah. So if you've got a generator, you don't have to worry about getting a different one. You can probably use the one you've got. We'll be right back. So here's the question, class. WWKD. And I ask myself that almost every day. And that stands for, what would Kyle do? So as I'm working here on the farm, I think about Kyle from Montana, Kyle Harris. I mentioned his name earlier in this broadcast about living living off the grid. Welcome, Kyle.
Good morning, Vince. I just had some comments to put some kind of an exclamation point on what your guest Rhodes is saying there. Out at the farm where I used to live, I put up 2 telephone poles, used telephone poles that were, 6 feet in the ground, and went up there and put a wind generator on them. And if I had it to do over again, I would never have done that. They are high maintenance. I can just guarantee you from living with one that unless you put the pole very close to your house, or you buy a wind turbine that produces 110 volts, and then you have an inverter that will invert it down to a usable voltage for the batteries, buy more solar panels. That's my suggestion there. And then if you put it very far from the house, you're going to have to... Go ahead.
Tell us why again. Does it have to do with the pole itself, the organisms eating the wood of the poles and the decaying of the poles, or is it lightning striking the poles, or is it climbing up there to lubricate the gearboxes, or what is it?
Well,
that makes this high maintenance.
I had a spark arrestor on that, and I never did have lightning strike it. But what I was getting at is I had a pole. At the top of this pole, I had a 2-inch galvanized steel pole that ran up that held the wind generator on top of it, and it was bolted to this steel pipe. Well, the steel pipe, I bolted it to the telephone pole with 2 half-inch stainless steel rods, long bolts. And with all of the torque that you get with a wind generator, those things would I had double nutted and everything else, but it just ate into the wood with all of the torque that they continually had. It would just eat into the wood, and it would start loosening up, and then the pipe would start moving around, because we would get high winds in the spring and the fall. But overall, if I had it to do again, I would never have wasted the time and stress and trouble of putting up a wind generator. Now, hydro has one other kind of a consideration there. If you live in the northern climates and everything freezes, you're going to have to build some kind of a heating box over it for the water, to cover that. Because if the stream freezes, you're done. It's not going to do it. It has to be able to. Your hydro system has to be able to be moved up and down, because in the spring you're going to get a lot more runoff, and so you need to be able to kind of manage that as well. You have to be able to go down and up, like you were saying this summer. Your creeks were drying up. Well, if you have a real low flow, it's very difficult to run those. It's just, I just kind of put in an exclamation point. My point is, or my thought is that if you're looking at these systems, talk to this guy, Rhodes, or somebody, because there's a lot of things to consider. One other thing that most people don't even think of is phantom loads in your house, where your microwave has this display. Your oven might have a display. Those are called phantom loads. And even a gas dryer, the new gas dryers that are here now, they have a 600-watt electric igniter in them. That every time that if it cuts off, I'll hold through the break. That's fine. Yeah, I know we're coming up.
Yeah, Kyle. You're absolutely right about these loads that you may not know about. Even if you get a propane stove, we have the same kind of igniter in our propane stove, and that if we want to run want to bake or broil, that darn igniter is running 600 watts the entire time the propane stove is operating. So, yeah, you're absolutely right. Class, quick update. Upcoming events If you're interested in going to an RK gun show, Wichita, Kansas, that's October 1 and 2 this weekend. Wichita, Kansas. If you're in Missouri, Farmington, Missouri, RK gun show there. And that's October 1 and 2. And October 1 and 2 as well, Murfreesboro, Tennessee. And if you happen to be near Kansas City, Missouri, I'll be there tomorrow, Saturday, October 1, and Sunday, October 2. I'll be speaking about, I actually guarantee that I can save you $1,000 a year easily, just by spending 90 minutes with me at the RK Prepper Show. That's at the KCI Expo Center in Kansas City, Missouri. And there's information on the website. That's rkpreppershows.com. Rick Miller will be there. Matt Stein will be there. Craig Douglas, Storm and Norman Cantwell, and Dr. Joel Wallach will all of us from USA Prepares will be there. And maybe we can have dinner. Kyle's with us. Kyle called in from Montana. He was giving us some of his advice and experience based on generating electricity. Kyle, please continue.
Well, I was just going to say one of the other things that we did, we went through looking at a lot of different propane stoves because I tore out all of the electrical things like electric furnace, electric range that was in this house that we bought. And I piped the entire house for propane. And we looked at a lot of propane stoves, and we ended up, there was one at Lowe's that they sold that has, I think it's called a piezo electric igniter on the in the oven and on the top. And so these are, that's what we ended up purchasing. They even had a special on it. I think we ended up getting it for like little over $300. But anyway, it has worked perfectly. It does take a little more thinking. I mean, you gotta, when you turn the burners on, you gotta put it to light and make sure that it lights, that kind of thing. But anyway, that saves a lot of power. The thing we can't get away from, and that I have not been able to do yet, is the dryer that uses a piezoelectric system rather than that 600-watt igniter. I don't know if they make them, but I haven't had time to investigate them because I'm still building the farm outside right now. But anyway, that's just to throw out some ideas to people. The good thing is, I mean, if you have a big enough my opinion is this, Vince, that if you're going to put in a battery system, overbuild it. Get more batteries than you think you're going to need and get more panels than you think you're going to need. Because I guarantee you, you'll use them. I put in 12 batteries this time only because I found a set on Craigslist that was 7 years old, and they're the big 395 amp hour batteries, and I put in 12 of them. And out at the farm, we had 1,000 watts of power coming into 8 batteries, and here I have 1,800 watts of power coming into 12 batteries, and that just, you will use it. Mine will run my electric refrigerator, which we had a propane one at the farm. And, we went now for 5 months on a 500-gallon tank, and it was filled up to 83%. And I just checked it yesterday, and it's down to 70%. So we used 13% in almost 5 months. So people, you can do it, and I can run my house on grid or off grid. My electric bill, and we do run most of the time because I'm saving the batteries. I'll use them about 1 week a month because there's just so many cycles left in any of those lead acid batteries. Out at the farm, I was very careful with them, and I got 11 years out of the same kind of batteries that I have now. That's not typical. Most people will get about 7 at best. I agree with your guess there on it, but I was very careful. The other thing people might, if you put in battery system, the one thing you want to do is every month out of your budget, take about $40 and stick it in an envelope somewhere, and that's your battery fund. so that when they go down, you're not in a crisis. You can just go buy more. I just suggest...
Really good points, Kyle.
Yeah.
I have a question for you.
Sure.
You've been living off the grid for years. Do you have any regrets?
Oh no, not in the least. I love living off the grid, and my electric bill has been running around $33 a month, and 22 of that is the meter charge. So I don't regret it, and I'm running my well pump and everything off of it, and 2 freezers and a refrigerator. But it can be done. My wife and I are just so used to turning off lights when we leave a room. We're slowly changing all of our light bulbs out to these the LEDs, and I've got almost all of them changed in the house. So it can be done. You know, I don't regret it in the least, because the freedom to be able to, if the grid goes down, to know that, you know, we're set. We can go for at least a year or 2 minimum without having to purchase anything. You know, no power, no nothing. Sure, if it's in the middle of winter and you're still got everything running, there's some adaptations, you know, you're going to have to make. But, you know, that's just life. Life throws you changes all the time. You know, if it's really cloudy, you're going to have to wait till it's really sunny before your wife does laundry. So, you know, just those kind of things. I don't regret it in the least. In fact, I love it, to be honest with you.
Kyle,
go ahead. Yeah.
The reason I selected a hybrid system, and I want to share this because I'd like to get your opinion as well as Rhodes' opinion on this. The reason I selected that was because there are some things that I have to do now before I totally go off grid, and that is I've got to weld the track on a track loader, like a bulldozer, and it's going to take a couple days, literally, of sitting welding the track back together on this big piece of heavy equipment. So welding uses an enormous amount of electricity, and I don't think I can provide that for very long. I mean, just a few minutes with the solar system, off-grid system. That's one of the reasons why I decided to go with a hybrid system, so I could connect to the utility for those times when I need to draw an enormous amount of power, but very, very infrequently. Your thoughts on that? Has that impacted you, welding on your off-grid system?
What I decided to do, Vince, because Rhodes is correct. You can't pull that kind of power off of a system that is meant to run a house. It's not a commercial setup at all. So what I ended up doing is I hunted around and found a gas-fired welder. And that's what I run. If I need to weld, I'll fire up the gas-fired welder and run that. You can, for a short period of time, run a smaller wire feed off of it, but it won't last long. You'll draw the batteries down in a matter of, like you said, minutes, because everything runs off of, like you said, if it creates heat or if it creates a spark, then you're pulling a ton of amps. And off the grid, there's an old saying, you live and die by the amp. So that's what you have to watch more than anything else.
Rhodes, what are your thoughts on what we've just been saying?
I would echo what Kyle said exactly. If you wanted to do that welding project on the track, you could do it in about 5 minutes a day, and it would take you a year or 2 to finally finish that, because it would take all day to recharge that battery with your solar array, and you would drain that battery in a matter of minutes with a welder like that. So definitely have some gas-fueled welder, or if you had a backup generator on your system, that generator would be running constantly to supplement the solar. And in that scenario, you probably could do it in an off-grid situation, but you'll be burning a lot of fuel to get through that welding project.
So we're in total agreement. All three of us are in total agreement. Kyle, anything else you want to share with us?
No, I'll let you go ahead and finish the program. Very good information. I appreciate it.
Kyle Harris, thank you so much. Kyle lives off-grid in Montana, USA preparedness instructor. Thanks again, Kyle. Okay, Rhodes, we've been talking about these systems. What about if we start out with, let's say a 48-volt system, and we decide that, as Kyle said, we need more batteries than we thought. Can we add more? How would we do that? Or can't we do that?
You can add or upsize your battery bank, but there are some caveats that you need to keep in mind doing that. And I design systems for a number of people who want to start out smaller and then scale up down the road. And if we know that at the design stage of the initial system, it's not too much of a problem. But once you make the investment in your initial system, you really get locked into some certain options and really narrows down what we can do down the road as far as adding on to the system. Specifically, the voltage of the battery bank. Industry standards are a 12-volt system, a 24-volt system, or a 48-volt system. Once you pick the voltage of your battery bank, the appropriate inverter that you select, you're locked into that voltage. The only way you're going to change that is to throw out that inverter and buy another one. So that's the first thing. Secondly, in general, it's not good to mix old and new batteries together. You'll have some performance issues. Basically, the new batteries, they're going to work only as fast and as hard as the older batteries, which aren't going to have the same abilities as a brand new battery bank. So you're going to have some unrealized potential or capacity in those newer batteries when you mix them with older batteries. We also need to keep battery banks that are in parallel identically sized so that, again, we don't have any unrealized capacity issues. So there's some caveats, but if we know that going into the...
Let's talk about that a little bit more when we come back. What do we need to think about when we buy our batteries so that if we do decide to upgrade to a larger capacity later, we can do it without wasting money? Rhodes Carter, ironedison.com. Class, Rhodes Carter's with us. He is a system designer at ironedison.com. Rhodes, so let's say a person has a budget. Let's use me. Let's say I'd like to buy nickel iron batteries for our solar system, and I want to have a 48-volt battery bank. And the reason I want that is because if I'm starting with 48 volts to go up from 48 volts DC to 120 volts AC, there is less voltage difference between 48 volts and 120 versus 12 volts and 120. So I have lower losses in the cabling or the wiring system. So my system will be more efficient if I start with 48 volts, right?
Not necessarily. There's not really any significant efficiency differences between inverting 12 volts to 120 versus inverting 48 volts up to 120. The different voltage battery banks, the larger voltage actually just gives you inverters that are capable of outputting more power. And it gives you more energy storage capacity as well. To kind of put some numbers to it, the inverters on the market that run on a 12-volt battery, they typically max out at about 2,000 to 2,500 watts of total output. So that's all the energy or power they can output. 24-volt inverters typically range between 2 kilowatts and 4 kilowatts of power. And a 48-volt inverter, like the one you have from Schneider, can be 4 up to 8 kilowatts. I think yours is a 6.8 kilowatt that you have. Mm-hmm. Right. So it just depends on the power needs that you have and the energy storage. Mm-hmm. If you're in a larger, 2,000 plus square foot full-time residence, you're probably going to have a 48-volt battery bank or a 48-volt energy system. On the other side of the coin, if you have a small one-room hunting cabin or a vacation home, you could probably do 12 or 24 volts there because you don't have the power requirements or the energy storage needs that you do in a full-time residence.
Yeah, there's one little piece of information I need to give you that I didn't add to that, and that is that the solar array and the charge controller is about 80 feet from the inverter. So that was the voltage loss that I was talking about.
Oh, okay. Yeah, that's on a different level. You're not inverting from DC to AC yet. You're just taking the DC voltage from your solar array, which is probably going to be about 100 to 130 volts DC, running that through a wire, into your inverter room. That's where it'll hit the charge controller, where the charge controller then steps it down to the battery voltage. And it's kind of a throttle, if you will, to make sure you charge the battery properly and efficiently.
So let's say we started out with a 100 ampere hour system at 48 volts, and then we said, you know what? Why don't we make it double? If we already have a battery bank of nickel iron batteries at 48 volts or 12 or 24, whatever it may be, and we decide to double that capacity, if we get the same kind of batteries, can we just add another 48 volt system in parallel and now have two of them? Would that be acceptable, or would we have problems with that?
That's really the only way you can do it. You can add a second battery bank with nickel iron or really any other battery chemistry. The caveats are that the new battery needs to be identical to the old one as far as the voltage, the amp hour capacity, even the chemistry of the battery, because different battery chemistries run at slightly different voltages. So it needs to be the exact same size and capacity battery in order to parallel them. And industry best practices is that you want to have no more than two batteries paralleled together, or battery banks. You can go up to 3, but that's really the absolute max. You get any more than that, and you're going to wind up with some balancing issues where one battery bank will have more energy than the other one, and you'll get into some unrealized battery capacity at that point.
Great discussion. Absolutely fabulous. In class, if you'd like more information, I suggest you consider calling ironedison.com, 720-432-6433, 720-432-6433, ironedison.com. Rhodes Carter's been with us, and if you'd like to email him, Rhodes, R-H-O-D-E-S, at ironedison.com. Any last-minute 10-second thoughts, Rhodes?
I can't fit much in 10 seconds, but to say thanks for having me on the show. It's been a pleasure, and looking forward to joining you again sometime soon.
That sounds wonderful. Rhodes, thanks so much for helping us understand this, what is apparently difficult at first, but gets easier and easier as we go along.